Hello Sacred Geometry Decoded SGD. You'll find the full playlist to this particular series and a couple of related ones in a description. I'll also put the link to the previous episode in the description. And this theme, now it's been a focus on the Great Pyramid, but also been touching on other ancient sites, other ancient civilizations, and this very symphony of coincidence when it comes to their systems of weights and measure, how it corresponds to their temples, how the inherent measures but also the inherent proportions of these temples repeat a very lovely system which essentially incorporates some fantastic knowledge in regards to the quadrivium, so geometry, music, arithmetic or math, and astronomy. And to extend from, I'll show some links as well to some other researchers to extend upon that, to show that through this measure and geometry, so especially the proportions of geometry, the mathematical constants are universal constants. They remain true as language changes, as religion changes, as politics changes. There are a few truths that we can always rely upon, and they are essentially the geometric constant. Because it doesn't matter where you live, it doesn't matter if you're on Alpha Centauri or here on Earth, there are certain rules that follow and repeat throughout the universe. These are universal truths, and it's just a lovely symphony of coincidence that the temple proportions, the weights and measures, but also mythology in regards to certain sacred numbers can be found cross time, cross cultures, cross the world, whether it's ancient or modern. They're still being repeated, and they're embedded in the architecture. They're also embedded in the standards of weights and measure. Now, if you think about international trade, it's based on certain standards, whether it's the meter or the foot, the size of a shipping container. These things are universal standards that we all rely upon, and they're embedded with the same system of knowledge. And so if you look at the ancient gods, so Thoth and Shesset, but especially Thoth or Djibouti, or the Egyptian god of connected to knowledge, to maths, to architecture, to chemistry, or just alchemy, also the god of weights and measures. Now Hermes or Mercury, same thing, god of commerce, god of weights and measures. Nuar and Fuzi in ancient China, we see the same, but we also find them in Sumer and other places across the world. But the gods of knowledge, the gods of architecture, are the gods connected to weights and measures and navigation. And when we think of weights and measures, we tend to think of the ruler, maybe the compass to measure angles, the pan scales to measure weight. But standards of measurement include time. This is a very, very important feature, and this will relate. Now, geometry, it's all geometric, even geometry, geo, earth, metry, measure. The connections between ancient measure systems and geodetic measures, earth-based measure systems. Even say the original French meter was based on the earth itself. Now the meter has changed, but it's still based on the second, and the meter and the second are wonderfully linked. I'll put some links in the description. So in the previous video I was focusing on 3.3 foot, and that being a pendulum. Now as an example, okay, so where are we? Over here. Alright, so previous videos. Now the wonderful thing about this is you can do it at home. You can do these experiments. Now for instance, I've just got 3 pendulums here. So the original, let's call it 1500s, 1600s, the original 1 second pendulum of just a fraction under 1 meter long. Here we have a 1 meter pendulum, and that's and all of these are 30 degrees, and that's an important feature. If you extend a pendulum over 30 degrees, you affect the timing. But the 30 degrees, so many connections in there, I won't go into that now. But what we have is, for instance, the modern meter, that 30 degree arc is 1 Egyptian royal cubit, or E minus 1 feet. But the pendulum, so the last video was on 3.3 foot, and this is the pendulum I'm speaking of here. All of these are very, very accurate 1 second pendulums at various positions on the Earth. As you move north or south from the equator, the pendulum changes because there are the effects in a very slight effect. For instance, in the centrifugal, so the spinning of the Earth at the equator, it's ever so, because the Earth spins once every 24 hours. It's often said that the speed, anyway, you might know what I'm talking about, but the speed of the Earth rotating is not the point. It is the RPMs, and so if you spin a globe, you have to spend a whole day spinning it. That's the important factor. But that's off topic. But what I'm saying is what we have is these free pendulums. They're basically 5.6 mils difference as you grow, and the difference between the Egyptian foot and the modern imperial foot is 5.6 mils. But this pendulum here of 3.3 feet creates a very accurate second, but it also describes other units of measure. Okay, so again, like in an earlier video, I did a comparison, so where we see these different pendulum swings. My computer going to play ball. That's freezing up. But so 1 second, and how 1 second pendulums is essentially either a meter minus 5.6 mils or a meter plus 5.84 millimeters will give you these very effective pendulum systems. Okay, it's not playing. It's free, but again, it's plenty of research. It's testable, and it's also something you can do at home. And the connections to the Great Pyramid or the Parthenon or ancient India, ancient stone circles, everywhere in between. Such a symphony of coincidence that it boggles the mind in many ways. Okay, so again, yeah, 1 second pendulums at 30-degree angle, how through this system it all just joins together wonderfully. We can close these off. Okay, so Alan Butler, I'll put the link in the description. He talks about pendulum systems and how ancient peoples, and he speaks about the importance of essentially saying that, for instance, the stone circle builders were essentially the bureau of weights and measures of their time, something very similar to John Neal talks about. I linked him in the previous one. And in this particular video by Alan Butler, speaking on the pendulum connections to astronomical events and also to, well, architecture, such as the stone circles. And he speaks about 366 megalithic yards. Now, you might be familiar with this number, 366, and how it's been suggested this connection to many sites across the ancient world. He also speaks about how the town plans, for instance, of Bath in England, which has some very interesting architecture, the symbolism, including the Doric, Ionic, and Corinthian columns, but also Washington, D.C., where the Naval Academy is, I think, but again, that's a center of astronomical and measure systems in the US. How the 366 megalithic yards describes these circles in modern architecture as well as in ancient times. That link will be in the description. Also put some info in regards to Roland Boucher. He's done a lot of work on pendulums and the pendulum and standards of measure in the ancient world. He's looking into this as well. Now with some recent work, for instance, metrology studies of Mark Wilson Jones has narrowed down these ancient measures, and so when we come back to the meter, so especially when we start looking rather them individually, whether it's a megalithic system, which is contentious, or these other more verified systems, we are now through the meter, the second, the cubit, canonical cubit, mathematical constants joining all these systems. But as we can see, remember 366 in regards to Alan Butler's work. Well, in the work of Roland Boucher, he talks about this 366 to 360 system as well. I'll put those links in the description. And again, as new data, new studies have come out, and people are taking measurement more seriously, it just tended to be rounded off. It wasn't but what we find is wonderful stuff is happening here. But also can be very confusing. So if you read these papers, it can be so what's an Attic or Athenian foot, Minoan foot? It's very, very tricky. It's very difficult because so often, like we know the measure, but they get, well, yeah, it's a very tricky subject, unfortunately. But whether we're relying on the study of architecture or surviving measure rods, etc., but the importance is the number. So it's if you read it, it can be a bit conflicting is what different names are, but if you focus on the measure itself, that's a key point. Yeah, it's very, very confusing for the uninitiated in this particular area. So previous episode was a focus on 3.3 foot, that pendulum, 3.3 feet. Now, this 30-degree angle, this pendulum, that would form this portion here. So now we're looking, instead of the radius of this circle formed by the 3.3 foot pendulum, we'll be looking at the diameter of that, which is 6.6 modern English feet. I can close these off. Yeah, now, yeah, so I'll try to put these, it's in the playlist if you go back. I mean, the last, yeah, it's all there. And anyway, so close that off, close this off. Okay, so now we'll be looking at 6.6 feet. And also, as I mentioned earlier, the geometry to create this 30-degree angle has so many other connections and symbolic connections, such as the Templar cross. Okay, but 6.6 feet. Now, it just so happens that 6.6 feet, or 105.6 digits, there are 16 digits per foot, and there are 12 inches per foot. But that just happens to convert to 99 Doric or 110 Ionic. And that pendulum, the straight line across, not the arc, but the straight line across, is essentially 1 Samian cubit, or 27.33, etc. fingers, and you can see meters and feet in there. This is a very important number, but what we have is the Samian, the Doric, and Ionic coming together, and the difference from the Samian is less than half a millimeter. So now I'll just move this over here. So Samian, Doric, and Ionic. If we look at the Salamis stone, which is just like the Parthenon itself, just like the pyramid, just like so many of these ancient structures, it is a conversion point between multiple sets of measure at very beautiful numbers, very important numbers. And we can see that this symbolism, but also the architecture, for instance, Freemasons before, up until, if you go back roughly 200 years, Freemasons, stonemasons, architects, now we have free and accepted masons, so basically anyone of any profession can join. Prior to that, masons had to be masons. But the Doric, the Ionic, and the Corinthian, the importance of this symbolism, the three Greek schools of architecture, through the study of ancient architecture, but also through artifacts such as the Salamis stone. Mark Wilson-Jones has shown so many other places. This is not a one-off. There are so many of these types of stones around the world, especially in the Mediterranean. But we have these units coming together. So the Samian, Doric, and Ionic. The Doric, the Ionic, and the common foot, which is an English foot, but also the perimeter of the Salamis stone also incorporates the Samian scale of units. So we have these, and through this 6.6 feet joining nicely. Now, as an example, that this extends far beyond the ancient Greek world. So this is the famous Iron Pillar of Delhi. At the top of the column, it is 1 foot diameter, the modern English foot, again in so many examples of it in the very ancient times. And the capital itself is 3.5 feet. I've done a video on this, I won't go into the deep, but when you convert these particular numbers, you have amazing astronomy connections going on. But the Iron Pillar itself, which is partially buried, is in total height, including the buried portion, 27.33 feet, give or take a fraction, or 27.33. And what do we have? Again, this Samian 27.33. This is a very important number, not just as a measure systems. You'll find that this architecture will, including the pyramid, for instance, will convert over to 27.3. So important in astronomy. But as an example, I already mentioned, so 3.3 feet or 6.6 is a direct conversion to the Indus Valley, so Mohenjo-Daro, for instance, and Harappa. Well, what were their weight scales? Well, there you go, 27.3. Is that correct? I might have made, so one copper deben, let's call it. This might made it. Anyway, the ancient Egyptian system of measurement, also at 27.3 grams. And just so happens that the Greeks and the Romans were also using a 27.3 gram system. So just like the meter being modern, the metric weights as well at these very important specific numbers, well, exhibited in so much of the architecture and in the surviving artifacts as well. what we have here is is a coordinated, lovely system. When it comes to the importance of this number 27.3, I've covered it in detail in earlier episodes of this series, playlist in the description, and some standalone videos. But the pendulum of 1 second, you need to have a specific length to find the timing of 1 second. And so time and length, weights and measures, measuring length and measuring time is connected, and of course measure systems. But for instance, why 27.3 if you haven't seen? Well, the moon is 27.3% the size of the Earth. That's a relationship of distance, or the diameter of the moon, 27.3% the size of the Earth, while it takes 27.3 days for the moon to orbit the Earth in relation to a star. So now we have measuring time, measuring the sun, and the sun is connected to, but for instance the moon, measuring the relative size of one, measuring the time, 27.3 days, and also the meter and the metric system, how that connects to, well, time, measure, astronomy, geometry, it's all linked in. So we've joined the ancient Greek units of measure, and of course still it's been passed on, and in the esoteric world, especially like Masons and Oddfellows, for instance, Rosicrucians, and symbolism connected therein, linked to astronomy, measure systems. I did a series on it, I'll put that link in there, but there's also a unit called the Longfoot. Now Mike Parker Pearson has been the main one to talk about this recently. He was looking at these items called the Folkestone drums and how they connect to the Longfoot. So 1.056 feet equals 1 Longfoot. 1056 is 33 times 32, which is another nice connection in regards to a lot of this old symbolism. Now, for instance, he was speaking, for instance, at Stonehenge. Now, the actual diameter of Stonehenge can be a bit tricky because the stones aren't perfectly flat. They bulge out, for instance, and the diameter of Stonehenge can vary between 105.6 feet, 1056, and 108 feet. Also that there are so many other stone circles of 108 feet and 105 feet together, but that's in the Longfoot playlist. I'll try to remember to put that in the description. But by using the Folkestone drums, and so just like the Parthenon or the capstone next to the Red Pyramid, the Salamis stone, the temples themselves and other artifacts show standardized weights and measures and how they're embedded. Now, for instance, the Folkestone drums, if you wrap a length of cord around it, the small one, you wrap a cord, so it's 10 long feet. You wrap a cord, and this would be convert to 8 long feet and 7 long feet. But also more to that, the lintels at Stonehenge are 10 long feet long, or 10.56 feet. So it's, again, there's a lot of the rings around them, the henge itself. The henge is the earthworks. The stone circle is not a henge, it's the earthworks. But we find that these correspond, and they're at like 300, 270, 360, for instance. Very important Pythagorean numbers related to music tuning and other elements as well. So not just the architecture, but also some artifacts suggesting this, and even the geometric designs might be a clue to in there. Richard Heath, for instance, in Sacred Number and the Lords of Time, he's Richard Heath, John Michel, John Neal, some very important people in regards to ancient metrology and geodesy, or how that relates to Earth measure. They also speak, they call it the root canonical Persian foot, 1.056 feet. This whole topic can be very, so if you just do like a Wikipedia type of search, you're really not going to get to it. It's very complex, but so the Longfoot, which has been connected to, for instance, Stonehenge and other ancient sites, with nice links to the megalithic yard of Alexander Thom, but it's also connected to the Persian foot. So one long or Persian foot, 1.056 feet. And so 6.6 feet, the diameter of this circle, would be 100 long digits or fingers on that scale at 1 point. 105.6, 1.056. So we have the doric, the ionic and the Samian coming together at 27.33 fingers. And now we have the Sumer or Babylonian, I'm just going to call it Mesopotamian for the moment. Those units of measure, how they connect as well. So 6.6 feet equals 6 Babylonian Sumerian, which just happens to be the Saxon or the Belgic or the North German foot. From the text, we know how the Saxon was divided down into inches and grains, for instance. That's still the same system we use for the 12 inches per foot, 1 foot, 12 inches or 16 fingers, etc. Or 36 grains or barley corn. The Sumerian system, that's how it breaks down there into cubits, feet, digits, and grains. And again, for instance, 720 or 216. These are all, again, your harmonic Pythagorean numbers, which will connect to so much geometry, astronomy, music, and lovely arithmetic as well. This is just a screenshot from the Wikipedia page on Mesopotamian measures, but so whether it's Sumerian, Akkadian / Babylonian, Mesopotamian, we see how they divided their units up. Now that's an interesting one because, for instance, Sumer, the base 60 number system, just like 60 minutes per hour, 60 seconds per minute, each degree of the compass, 360, is then divided into 60 minutes and then into 60 seconds. We see the same basic system, for instance, 12 inches per foot, that type of stuff. Okay, which brings us back to very early on in the series. I had a focus on Vitruvian Man. So this is from the Roman architect Vitruvius, which would be ancient to us, but he talks about the symmetry of temples and how the symmetry of temple design corresponds to the symmetry inside the human body. Man is the measure of all things. And so how the divisions of the body bring us to these lovely numbers which are found in temple design. He even describes how the ancients, this is the ancient Roman architect describing how the ancients to him were embedding this system in there. And of course, the pyramid and these other sites we find, so it's just there. So the cubit from your elbow to your finger, as is described in Vitruvius, the human body is 4 cubits high and 4 cubits wide, ideally speaking. Of course, we're all individuals and slightly variations, but the inherent geometry, if you take one random person, it might not fit, but if you take 1,000 people, the average will come closer and closer to this particular point. Also, the connections between the golden ratio as well. You also can see how the center forms right on that particular part of the human body. If it was male or female, it's essentially the same thing. But 4 cubits, well, 6.6 feet is 4 Babylonian Sumerian cubits or 4 Saxon cubits. Therefore, the idealized Saxon or Babylonian figure would be that 6.6 feet or 2 meters and 1 centimeter and a fraction. By studying city and temple plans along with artifacts as surviving rulers from ancient, like the measuring rods from ancient times, as well by studying statues, archaeologists such as Petrie and Mackay, and earlier they paid much more attention to metrology back in the day, but they were able to determine the measure systems as well. So what I mean by that is that the idealized human, yes, but more than likely, and by the evidence itself, you don't take a person and use them as a measure, because a person shrinks and grows over time, and even people can change. It's not a very effective, efficient system. It would be more likely that it's embedded in artworks such as sculptures. This way the measurement stays strong and it can be used throughout generations, because people, within a lifetime, people change very often. Even within a year, depending on your health conditions, you can lose or gain height. So it's much more logical, but also by the evidence itself, that these type of measure systems were built into the statues, rather than finding a person and saying you're the idealized person, we're going to use you as the basis of our measure systems. Because when you're paying tax, you want to be accurate, and for instance, and when you're paying or collecting tax, you want to know. So it's not a good system to use an actual person. It's much more likely that it's built into the architecture, which of course it is, but also in artwork such as statues. Now, for instance, so the idealized Babylonian Saxon person would be 6.6 feet. The idealized Egyptian, Old Kingdom Egyptian, would be 6.87 feet, because that's 4 Egyptian royal cubits wide. Now, the cubit, we have surviving ancient Egyptian cubit rods, but for instance, in the Great Pyramid, the Grand Gallery is 4 Egyptian royal cubits wide. The King's Chamber is 20 royal Egyptian cubits long, or 10 wide, and even the air shafts, the so-called air shafts, but the shafts in the Great Pyramid are half a cubit wide and half a cubit high. This and so many other sites, we know what these are, and it's not just the surviving measuring rods, it's also found in the temples themselves. This is a very important feature in regards to understanding their sciences and their knowledge systems. Just like now, weights and measures is the basis of our science, it's the basis of our economy, as it was then, to have standardized weights and measures. But again, this principle is described by Vitruvius, man, or Protagoras, man is the measure of all things, and the symmetry of the temple, that the larger part should be correspond to the smaller parts of the temple, which again is found in the architecture. Now back to 6.6 feet, or 6 Babylonian feet, or 6 Saxon feet. Well, the ancient Indus civilization, Mohenjo-Daro, which had 27.3 gram weights as well, but 6.6 English feet would be 6 Indus feet. So again, this corresponding between these ancient systems crossing time, as well as the very important 27.3. Now, unlike the Babylonian or Belgic Saxon system, as with the imperial system, it seems that the Indus, there's a lot of evidence for it, they divided their foot, let's call it, into 12 smaller into 10 smaller units. So again, this the metric system being based on tens and hundreds, you'll find this so often throughout these important systems as well. And so again, back to the Akkadian or Sumerian system, where we see these divisions based around the base 60. I bring this up because back to the Longfoot scale, where we have that sort of divisions. Now the Longfoot or the Persian foot, you can see here, this is again this is a good example of one of the problems with, you really have to dig deep, because if you go, for instance, just on Wikipedia, they'll tend to have, the divisions of the Persian Empire, how they divided up. But you'll note that and it's a really, really big problem with Wikipedia and these type of sites. Now, for instance, say 20 millimeters is 0.8 inches, or 300 millimeters equals 1 foot. Well, no, 1 English foot is 304.8 millimeters. So just a heads up, you really can't rely on the conversions are just so bad in these types of sites, and even most of the archaeology sites, they just don't convert very well. And it's actually very simple to do, but they don't take it seriously for whatever reason. But back to the Persian or the Longfoot, here in this particular, I've divided into fingers or digits, and that would be 100 to 99 Doric to 110 Ionic. For simplicity, I've used the digit or the finger 1/16, so 16 fingers is a foot. I've said that for simplicity, but for instance here you can see, if you do, you can spreadsheet it, and you'll find that you'll still get your neat conversions going through there, and I'll still be coming to these very important harmonic numbers as well, but just as a heads up there. Okay, so 6.6 feet, the long, the Doric, the Ionic, the Samian, the Sumerian, the Indus, also the Saxon Belgian foot connecting, and we'll get to more in regards to the imperial system of 6.6 feet, because that connects to the Gunther's chain as well. But okay, now back to, this was a 1 second pendulum based on that section of arc. So that section of arc is 1.7278 feet. This is an important feature, because now we're going to connect as well. So back to John Michel, Richard Heath and others, and this unit of measure that they've, by studying ancient sites, what they call the canonical cubit of 1.728 feet. This canonical cubit of 1.728 feet, now 1728 if you're into your numbers, you'll notice that's a lovely number as well, but this particular unit, Richard Heath, John Michel, who are pretty much very, very important in this field in regards to metrology, studying ancient architecture with a different perspective. I'll also put in a link to the description. John Neal, talking about ancient metrology. He's, again, a very important researcher in this field of the ancient measurement, essentially ancient science, because these measure systems, how they connect to geodesic, as in earth-based measure systems, or geometry, geo, earth, metry, measure. In his short talk, he points out the importance of weights and measures and how the builders of stone circles, ancient temples, right up to modern cathedrals, modern buildings such as US Capitol building, and major cathedrals even now, major public buildings, incorporate this same system. Again, this whole channel's devoted to this particular study. He talks about how ancient sites, including Stonehenge, Great Pyramid, are monuments to weights and measures. And now, as my sort of especially this focus on pendulum weights and systems as well, just to add to this, and it is there's so much tangible, measurable, testable information in regards to this. It poses some very important questions about the sophistication of the ancient people. But then that must be compared to, say, for instance, in the last, especially since the Renaissance, our measure systems and measurements of the Earth, distances to Moon, etc., were done with very, very simple tools. It does not require lasers. It does not require ultra sophisticated computers, modern technology to do this. There are very simple techniques to do this. It's not the technology that's important. It's the logic and the science behind it. It can be done, and it was done only a couple hundred years ago. They were able to do this to very high precision, and we see the same precision in ancient systems. But in this particular talk, he touches on the fact that 5 Egyptian royal cubits converts to 6 sacred Jewish cubits. Again, this whole field is, because a lot of it's reverse engineered, but the connections between these measures, how these lovely harmony points, is very important. Now, this 6 to 5 is very, very important to the canonical cubit of 1.728 feet. Geodesy, branch of mathematics dealing with the shape and area of the Earth and large portions on it, has to do with geometry, as in geometry, geo, earth, metry, measure. That's even like the meter comes from the Greek word metry, is measurement. Okay, I'll put the links, now going back to the late 1800s, so Charles Piazzi Smythe, just before Petrie, the antiquarians, the Egyptologists, were very, very interested in, they were polymaths, so were astronomers, geometricians, and for instance, International Standard magazine from 1884, you'll notice Professor Charles Piazzi Smythe, Astronomer Royal for Scotland. These, including Petrie, but even earlier to him, Piazzi Smythe, and even going back to Newton's ideas on the pyramidal inch, for instance, which is, anyway, I'll leave that for the moment, but what do we have here? The International Standard, a magazine devoted to the discussion and dissemination of the wisdom contained in the Great Pyramid of Giza in Egypt. The International Institute for Preserving and Perfecting the Anglo-Saxon Weights and Measures. This is a very, very important field in regards to this, and because it can be measured, it can be tested, and because it involves maths and geometry, it's anyway. But again, we see that the International Institute for Preserving and Perfecting Weights and Measures. Essentially the quadrivium, where we have multiple disciplines coming together in very interesting forms. Music, geometry, astronomy, arithmetic. That's the quadrivium. Now, what links the quadrivium is it's measurable. So whether it's navigation, weights and measures, commerce, it's founded in here, and you'll see again astronomers, very important feature. Now, Thoth, Shesset, Hermes, Nuar and Fuzi, guides of weights and measures, guides of commerce, guides related to architecture, navigation, and these particular types of fields. The Committee on Standard Time, which involved this back to the international standard, includes Charles Piazzi Smythe, his very famous early Egyptologist, in regards to his work on the pyramid and the measures and the angles and contain variant. And of course, this is not just in the Great Pyramid. This is about earlier episodes I've shown this through the geometry, how all of the pyramids are connected through very important geometric constants such as the Fibonacci numbers, golden number, the Vesica Pisces, for instance. But Charles Piazzi Smythe, Astronomer Royal for Scotland, and Committee on Standard Time, pendulum, weights and measures. All right, so for instance, he was connected to the first 1861, the Edinburgh clock. This was Piazzi Smythe. This was to find time, very important for sailors, for navigators, to get this very accurate. For instance, train operators introduced the first standardization of time in the US, but also in England and Europe, the idea of having an international standard of time was one of the great leaps forward in international trade. If we didn't have standardized time now, all of our GPS, our internet wouldn't work. We need an international standard. So it's not just a philosophical hobby. It's essential to our international trade, to our sciences. And these people who were investigating this were astronomers, timekeepers, geometricians, hermeticists. So the connections are modern 1 meter pendulum of 1 second is 1 Egyptian royal cubit, 86,400 seconds per day, which is pi over 6 meters, pi over 6 radian, or 30 degrees, which converts, for instance, to 108,000 seconds of the compass. The connections, again, earlier in the series, I won't go at, but measurable, tangible, so important to the modern world, and of course the ancient civilizations, Egyptian, Sumer, and the Indus, relied upon standardized measure systems, and it just so happens that they incorporate geometric mathematical constants which are essential to universal truths. So back to John Neal, and for instance he spoke of the 5:6 ratio Egyptian royal cubits. Well, the canonical cubit of 1.728 feet. The Great Pyramid, the section above ground is 5, but if you measure from the top of it to the subterranean chamber, it is a 5:6 ratio. The bent pyramid, if you unfold them, what you get is a pentagon and a hexagon, a 5:6 ratio. So important. Now, if you go back, for instance, to the works of important people such as Athanasius Kircher, the 3-4-5 triangle, 1, 2, 3, 4, I mentioned that's the tetractys. That's all the tetragrammaton. So important. Might notice the Serpentine River, but anyway, what's he got here? It's a 5:6. This is very important. You also notice the nonagon, but the 6:5 ratio to the geometricians, to the hermeticists, essential. Now, a canonical cubit of 1.728 feet, well, that's 6/5 cubed. And back to the pendulum of 3.3 feet radius, or 6.6 feet, but that 1 second pendulum of 3.3 feet creates an arc of 1.7278, etc. feet. That is less. I got the decimal point. Well, it's actually, I think the decimal point might be over there where it's 3.78 millimeters. But I think even if I've got that snafu and the decimal point should be there, we're talking a tiny margin of error. And again, in any other, if you achieve this margin of error, even in everywhere except for maybe aerospace, this margin of error would be just not, you could just rub it out because it's